My name is Alexis Weber, and I'm a fourth-year PhD student in the Department of Chemistry, obtaining a degree in analytical chemistry with a forensic focus. And my dissertation work is the analysis of bloodstains in crime scene conditions, specifically heated conditions, to determine their time-sense deposition. I'm doing this work to help improve the lives of crime scene investigators and forensic lab analysts. When they obtain evidence, it is their job to get as much information from the evidence as possible. This includes being able to determine which stains are relevant to a crime versus those that are extraneous, and this can be done by determining a stain's time-sense deposition. Previous work in our lab has been able to age a stain up to 2 years post-deposition, but that was done under ambient conditions. However, not all crime scenes have the luxury of being committed inside of a laboratory. Some are left in extremely heated conditions or extreme cold conditions. So my research has focused on the analysis of blood stains that have been aged in extremely heated conditions, up to 55 degrees Celsius, which mimics the inside of a car during summer. So the way this works is, for my research, I deposited blood onto varying substrates, such as shown under part 1 of the figure. Those samples were then analyzed using a Raman spectrometer, shown in part 2 of the figure. A Raman spectrometer works by using a single wavelength of light to irradiate the sample to excite the molecules within the bloodstains, which will then produce unique spectra, such as shown in part 3 of the figure, that will be representative of blood. As the blood ages, one of the main molecules within blood, called hemoglobin, will change its orientation over time. By tracking this, we are able to monitor and measure the time post-deposition by measuring these changes to hemoglobin. So the results that we would get are shown in figure 4. So for a quote case at a specific time or date when it's analyzed, the analyst would be able to say, this stain is blood and it's been deposited 5 hours ago, and even more, they could go 5 hours, a week, or 2 weeks post-deposition, depending on when the stain was collected. So this research can help forensic investigators solve crimes faster by knowing when a stain was deposited, and therefore which stains are actually relevant versus those that are extraneous, and help with legal proceedings going at a much more efficient pace. Thank you so much, and have a wonderful day.